Hey grade 12s, if sigma is a bit confusing, we're about to break it down quickly. So sigma is a series. It means we have to add up all the numbers in a sequence. We're given a geometric sequence here because we have a p in our exponent. So we do not have an arithmetic sequence or an arithmetic series. So that means if we have a geometric sequence over here, we have to see, do we go all the way up to infinity or do we end at a number? In this case, we do not go up to infinity, which means we aren't working with this formula and we are just working with this series formula down here. What we need to look at is our first input value. Our p equaling 0 is our first input value and our 8 is the last number in the sequence. So if we draw it as an input-output box like this, we go from 0 to 8. These are all the inputs we're working with and we want to add up the outputs of all of them. And that's where this formula comes in because we need our a, our r, and our n. We need to get our first three terms. If we plug in the first input, our 0 over here, we get t1 over there. If we plug in 1, which is the second term, into there, we get our second output over here. If we plug in 2 over there, we get our third output over here. But at this stage, our t1 is our a value. We have all three terms because we need to go t3 over t2, t2 over t1 to get our ratio. We will get the same value on both sides, and our ratio is how much we multiply the first term by to get the second term, and so on. So at this stage, we have our a, we have our r, all that's left is our n, because our n is our top number minus our bottom number plus 1. The reason we do that is because we have to include the first term, and if we go 8 minus 0, we will only have 8 terms over here, and we won't include the first term. So we go top minus bottom plus 1, plug our n value in, we have all the values in here, we can go ahead and solve for our Sn.